Set theory is the fundamental step in learning how the results of any mathematical functions would look like. This video will show the different ways of writing sets. Welcome to Mathematics of Engineering. Sets that are commonly shown as the configuration as the one shown. The capital letter A is the name of the set, and after the equal sign, there is a pair of braces to show that the entries within are in one group. Those values inside the braces are called elements or entries, and can be finite or infinite. This type of set form is called roster form or list form, as the entries are listed. Now let's discuss the different ways of writing sets. The first is word description when the sets are described in English words. With descriptions, a function can be written in different ways. Some examples are the group called A, which is a set of vowels in the English alphabet. Another example is B as a set of positive prime numbers less than 20. There is also C, which is the set of consonants in the word Philippines. The second way of writing sets is set builder form, which is also termed as rule form. From the name, this notation also describes the set, but not anymore in words. The sets are written in mathematical statements. In this type of form, there are four distinct parts. They are the curly brackets, variable, vertical bar separator, and the logical predicate. The curly brackets are called set braces. The variable is commonly x, although one can use different variables of their preference. The vertical separator can be a bar or a colon. The logical predicate contains the rules or conditions to describe the sets. An example of set builder notation is shown, and obviously it is a mathematical statement of numbers, variables, and symbols. Nevertheless, this can be interpreted as B is the set of with the braces. The x after is read as all values of x. The following bar is read as such that or with the property that. Then, the next are the conditions. In the example, there are two conditions separated by a comma and read as and. Let's leave the conditions as they are right now, as we are still gonna learn what the symbols mean. In here, we have the common symbols used in set builder notations. The first symbol is the squiggly E, which is the Greek letter epsilon. This means an element of or belongs to. The next notations deal with the families of numbers. N represents natural numbers. These are the positive whole numbers starting from 1 to positive infinity. The next notation is W, which means whole numbers. Whole numbers is just the same, the family of positive numbers, but this time with 0. The next one is Z, which stands for integers. Integers are from negative to positive numbers. Then is Q. This denotes rational numbers. Again, rational numbers come in the form of fractions or decimals, with a specific description of being a ratio of two numbers. Lastly, we have R, which stands for real numbers. Integers come in two. Positive integers are shown as Z with a plus sign, and negative integers have Z with a minus sign. Similarly, rational numbers also have Q plus for positive rational numbers, and Q minus for negative rational numbers. And yet, real numbers are also shown in R plus for positive and R minus for negative real numbers. An example of set builder form is written as D is a set of all natural numbers within 1 to 6. You can break down the descriptions and write them in mathematical expressions. First is natural numbers, that is shown as x belongs to natural numbers, given as n. The other description is within 1 to 6, which is written as x between 1 and 6. The word within means 1 and 6 are not included. So having translated all conditions into mathematical statements, set D can be written as all values of x such that x belongs to natural numbers and it is between 1 and 6. The next example, E, is a set of all positive odd numbers from 0 to 10. The first condition of positive odd numbers cannot be converted mathematically, so it has to be written as it is. The second condition, from 0 to 10, can be written as x between 0 and 10, with a less than or equal to sign. Now, we can express D as all values of x such that x is a positive odd number and it is between 0 to 10. From this notation, you can also see that instead of using a bar, a colon is placed to separate the logical predicate. The third notation is roster form, also called the list form. In this notation, the answers or elements are identified in a set grouped in set braces. Two examples are set F with -8, -6, -4, and -2. Another set is G with elements A, E, I, O, and U. Let's work on some transformation examples, starting with showing set builder and roster forms using the word description of the set M of natural numbers between 5 and 10 inclusive. For set builder form, we work mathematical translations where first, natural numbers mean x belongs to n. The next condition in this statement is between 5 and 10 inclusive. This can be shown as x between 5 and 10, within the equality symbol of less than or equal to. Now combine all math expressions to have b as all values of x, with the property that x is an element of natural numbers and it is between 5 and 10. The roster form requires identifying x. The first condition of natural numbers shows that the answers are positive numbers. Next is between 5 and 10 inclusive. This shows 5, 6, 7, 8, 9, and 10. So in roster form, set B has elements 5, 6, 7, 8, 9, and 10. Example 2 has a given equation of x squared plus x less 6 is equal to 0, and we have to transform its solution into set builder and roster forms. In set builder form, we can write set C as all values of x where x belongs to integers and x squared plus x minus 6 is equal to 0. The first condition of x as an element of integers is optional and can be taken out. The next notation is in the roster form where we have to look for the values of x. That is done by factoring the equation x squared plus x minus 6 is equal to 0. Through factoring, we get x plus 3 with x minus 2 as equal to 0. With 0 property, we can write x plus 3 as 0 and x minus 2 also 0. Then we can take x as -3 and +2. So set C is equal to -3 and +2. The next two examples are placed together to show their difference. Given the set builder form of set E as all values of x, such that x belongs to natural numbers and x squared is less than 50, write its raster form. First, interpret the first condition of x belonging to n. So x are natural numbers, which means they are positive. The square of x should also be less than 50. So we can limit x from positive and -1 squared as 1, 2 squared as 4, 3 squared as 9, positive and -4 squared as 16, 5 squared as 25, positive and -6 squared as 36, and 7 squared as 49. The last one is the closest square to 50. From the list, the first condition makes us consider only the positive roots of x. So, set E has the elements 1, 2, 3, 4, 5, 6, and 7. A deviation to the example is by a single symbol of having x as element of integers this time. With x epsilon z, integers are considered, and that means that positive and negative roots are accepted elements of the set. The lower and upper limit of the set are solved just the same, starting from positive and -1 all the way to positive and -7. Since elements are integers, set F has the elements of 1, 2, 3, 4, 5, 6, and 7, both negative and positive. The next example has a raster form of fractions needing to be translated into set builder form. Each element in the raster form is tagged as x. That means that the first element has x equal to 1 all over 2. With two different numbers for x, we should use another variable to notate them. Say, we assign n as the numerator. We can then assign the denominator as n plus 1. This is the first condition. The second condition is to further describe n. From the set, we can see that the numbers which we denoted as n are from 1 to 5. Take this as condition 2. Now write the two conditions together in the set builder format as set G as all values of x, such that x is n all over n plus 1, and n is between 1 and 5 inclusive.